Let's be realistic about the hype around domestic computing power. Implementing it is harder than expected and moving slowly. Researching the data center industry, how much domestic power is actually used in Chinese data centers? The official numbers say it's over 30%, even 40%, which sounds really promising. But when I actually talk to some friends in the data center business, people who are running or building data centers, the real percentage of domestic computing cards in use isn't even 10%. And that's not just for computing. Even for inference, which is the most common use case, NVIDIA is still the most cost-effective and widely used. In fact, in some small and medium-sized data centers, their main cards are NVIDIA's 5090s. Yes, that's right. You heard right. The 5090, a consumer card, now leads China's inference data centers. But aren't cards from Hygon and Moorthreads catching up to NVIDIA's H200? Then why is their installed base under 10%? This lags behind the domestic power narrative and defies common sense. So why is that? Are domestic chips themselves just not good enough? Not exactly. Top Chinese chips like Hygon and Huawei now rival or beat the H100 in specs. So why aren't they used? Let's look at the numbers for a mid-sized firm deploying AI inference. If you buy 100 high-end cards, NVIDIA's price is 1.5 to 2 times domestic brands. But they're ready to use, running in 2 to 3 weeks and fully compatible. You get global support and the CUDA community for any problem you encounter. With NVIDIA, 5 people can handle maintenance. Domestic cards are cheaper but bring many problems. Open source models often lack support for domestic chips, so you'll spend months adapting them or they won't run. Next is performance loss. Even if it runs, performance often hits just 60 to 70% of advertised speeds. Then there's the ecosystem. Switching manufacturers means starting your setup from scratch. You'll also need a 10-person adaptation team. If issues arise, support lags behind NVIDIA's efficiency. So despite domestic chips being 30 to 40% cheaper, with hidden costs, the total expense is much higher than NVIDIA's. Worse is the lag. If your AI business launches even a month late, competitors pull ahead. Time is worth far more than hardware costs. Deploying domestic computing power is hard, not because the chips are bad, but because the chain isn't connected. First, hardware often won't run. Many Chinese AI chip makers use different architectures, so migrating models leads to missing features and performance drops. The issue is immature software, not flawed chip design. Second, the industry chain is fragmented. Chip makers focus on single card specs, while integrators only care about hardware. Framework teams focus on tool usability, while app teams just want to go live. No one owns end-to-end efficiency. Despite everyone's hard work, users struggle to integrate different technical paths, causing friction. Third, building high-end clusters is hard. Running trillion-parameter models requires tens of thousands of cards, but domestic chips face networking issues due to fragmented interconnection protocols. Bandwidth is limited, and cooling and power are insufficient. A single card runs, but you can't build a cluster, forcing reliance on NVIDIA for large-scale training. These 3 issues create today's domestic computing dilemma. It's not that US cards are unavailable, they're just too slow and expensive. So after doing the math, business owners still end up buying NVIDIA. 5090, H20, that's why I said at the beginning that domestic alternatives really have a long way to go. So where's the breakthrough point? We can't keep relying on a single company fighting alone anymore. Someone has to connect the entire chain. I noticed that recently at the Tianjin Jibo Expo, there was something that actually put this direction into practice. Guanghe Organization, together with Hygon Information, officially released the Open Computing Token System. Finally, someone is starting to systematically address the issues I just mentioned. The name Guanghe Organization sounds pretty official, right? But if you look closer, their approach is completely different. Instead of single card speed, they focus on 3 areas. First, the Hygon CPU and DCU dual-core foundation. C86 handles general computing, DCU accelerates AI. Parallel deployment and coordinated scheduling are even more crucial. Crucially, C86 fits the x86 ecosystem, and DCU supports CUDA. NVIDIA code runs on Hygon with minimal changes, cutting migration costs. For efficiency, the Guanghe Organization integrated operating systems and databases with major software partners. Notably, Ziyuan's Flagos 2.0 stack already fully supports DeepSeek v4 on Huygens and 7 other AI chips. What does that mean? In the past, for a company to deploy DeepSeek, just adapting the chip alone would take almost half a year. Now, that's compressed to weeks. This solves the ecosystem silo issue. Third is engineering capability. Evidence shows that in 2 months, Huygens doubled its cluster to 60,000 cards. A domestic AI computing pool with tens of thousands of cards has finally started running for real. This solves the third pain point, the problem of not being able to build high-end clusters. If you look at these three things together, for the first time, deploying domestic computing power has become a collaborative effort across the entire chain. When companies do the overall accounting, domestic computing power is finally starting to make sense for the first time. This is truly significant. Now let me share a few of my own thoughts. First, the rise of domestic computing power is definitely not something that happens overnight. Over the next few years, NVIDIA will remain the top choice for Chinese data centers. That is the reality, but things will change. My second point, the shift to local chips doesn't happen at a product launch, it happens in the business ledgers. When using domestic products becomes cost-effective, domestic computing power will truly rise. This requires an ecosystem, not just one company. It takes synergy between Guanghe, Huygens, Z1, and 6,000 partners. This is the first time that China's domestic computing power has systematically carried the entire chain. Of course, we can't see immediate results today, but the direction is right. Finally, let me say this. In the second half of the game for domestic computing power, the issue to solve is not whether it exists, but whether it's worth it. The real turning point will be when companies, in choosing computing power, stop asking how much a card costs and start asking how much money a card can help me make in a year, how many tokens. That will be the true beginning of the rise of domestic computing power. That's all from me. Follow me and see you next time.